Okay, so problem 41 says, the path that you take to go from school to the library, shown in bold, is perpendicular to the path that you take from home to the park. Right away, what do you know about the slopes of those paths? They're opposite what? Opposite reciprocals. Great. So we know that. It says, write an equation that represents the path shown in bold. Now you may think to yourself, can't I just use this y-intercept and another point and find the slope and use that as a y-intercept? Yeah, you can definitely do that. But they were a little tricky here, and when they drew that line, a lot of the points, with the exception of maybe this one, are a little bit unclear. So really what we can do is find the slope between the path that we take to the park, find its opposite reciprocal, and simply plug in 3 for b. Does that make sense? So that's what we're going to be doing. So, figure this out real quick. Just a second. So let's find the slope between the park, or the points for the path to the park. So that'll be, this is 6, 1, and 2, negative 3. If I start with the 1 here, it's 1 minus negative 3 over 1. Over, yeah, 6 minus 2. So 1 minus negative 3 is 4 over 4, which means the slope is 1. So what does that mean the slope of the bolded line has to be? Negative 1. Right. So I have a slope of 1. The bolded line, let's put m of b, or m sub b, is negative 1, opposite reciprocal. And so what's the equation of that line? Negative x plus 3. And again, where do we get 3 from? Yes. The y-intercept that's shown on the graph. All right. Do you have any questions about that problem? The key, again, was perpendicular. What does it mean for two paths to be perpendicular? What kind of slopes do they have? Etc. All right. What kind of correlation is that? Negative. Negative. If we were going to draw a line of fifths, we would see that this has a negative slope. This line is going downhill, right? So because it's going downhill, it's a negative slope, which means the correlation is negative. Simple as that. On the final, they're probably just going to ask you a question like that. They will ask you just a question like that. What's the correlation? Negative, positive, or no correlation? Okay. It's really just a matter of identifying or describing your slope. And the slope is negative. Okay. Any questions so far? Okay. Give those two a try before we go over them. All right, what's our common difference for 43? Yeah, every term, if you look at every term, from term to term, it's going down by 5, exactly. So, oops, I'm going to unfreeze this. So minus 5, minus 5, minus 5. It's nice because on the final, they're not going to ask you to remember the formula. A sub n equals A sub 1 plus n minus 1 times d. Remember that? It looks like if this is what they're going to give you, then that's what you're going to get on the final, which is nice. So what's going to be our next 3 terms? Yeah. I mean, I'll take a look at your final, double check. But they try to make them very, very similar. So if I see something different, I'll address that on Wednesday. I will double check your final to see if there's anything that we didn't cover on the review. Okay, it says evaluate the function g when x equals -4. This is just figuring out which one you can plug it into given the constraints. So if we're given an x value that's less than or equal to -4, if we're given an x value that's between -4 and 2, or if we're given an x value that's greater than 2. So which one will I plug it into? Which will I plug -4 into? The first, second, or third? The first one, yeah. So if I plug -4, g of -4 is going to equal -4 plus 4, which is what? 0. Now you may ask, okay, what if for some reason I got a 1? If it said that x equals 1, and I look on here and it's this one, and it just says -2. Well, what's the value of g of 1 then? -2. Right. In this case, it's a horizontal line, right? Because you have g of x or y equaling a number, so it's a horizontal line. Does that make sense? If I said evaluate g of 0, it would also be -2, right? If I said evaluate, I don't know, g of -3, it would also be -2, right? Does that make sense? Okay, and then of course, if it was greater than 2, greater than or equal to 2, like 4 or 5, you plug it into this one. So this is a piecewise function. You just pick the one that it applies to. Any questions? Okay, great. I feel like you have a question, maybe?
Hey, isn't zero not less than -4?
No. This is solely talking about your x values, not your y's. So if you're given an x value of -4, your y value is 0. Yeah, the whole point was to plug in -4 and see what we get as an output, which is 0. This is just a restriction on your domain, not your range. Yeah? Good question. Okay, give this a try. Remember, this is the one where you have to do some erasing. All right, the trick to this kind of problem is to just graph the lines, and some of you don't need to do this, but again, this is what I like to do because it just helps me out. Graph the lines as though there were no restrictions, and then apply the restrictions later with an eraser. So, I know how to graph x minus 2, y equals x minus 2. What would be my y-intercept? -2. So I'm going to start at -2, and of course this will all be labeled for you. And then you're going to go up 1 to the right one, or down 1 to the left one, right? And then you're going to graph your line. We're going to take a look at the restriction and see what part of this line we have to erase, and if we have an open or closed circle. It says that x's, for this piecewise, x's have to be less than 0. Where on the graph is x 0? On the what axis? The y-axis. So, here is where I have an open circle, right? And for all the x values less than 0, that's going to be all of these values, correct? On the bottom? So what I'm going to do is just erase the top because I don't want any x values that are greater than 0. And I don't want to include 0. So I'm going to erase that and make an open circle there. Does that make sense? So that's how you graph that first one. Second one, the same thing. We're going to have a closed circle because it's greater than or equal to 0. So I know I start at 0, 0. I can leave that closed. And then I go up 1, 2, over 1. Well, I know it's not going to include anything down here, right? So I can simply just draw this part of the line. All right. Do you have any questions about graphing piecewise? just graphing lines like you're used to with a y-intercept, and then deciding where do I have open, where do I have closed, and that's based on your restriction. So if your restriction was 1, you'd find where you had 1 on the graph, like here, and make an open circle there. Does that make sense? Okay. Try these, please. Okay. We're going to go over your Chapter 5 test on Monday, and this is starting to get into Chapter 5. And what I noticed on Chapter 5, some of you made really silly mistakes on that kind of problem. And I was really caught off guard because it was not as hard as some of you were making it out to be. At least I thought so. So all you're doing is you're plugging in the point into both of those equations and you're seeing if it's true or not. If it's true, you say yes. If it's not, you say no. I think maybe some of you got confused between yes or no. I don't know what it was, but so on this one here, please don't overcomplicate it. All you're doing is you're plugging in -2 for x and 0 for y. And you're seeing if that gives you -8. And it does. -8 equals -8. That's a true mathematical statement, so yes, that'll work. The next one, plug in -2. So 3 times -2 minus 0, that does not equal -11. That equals -6. So that does not work. So this is one of our solutions to our system. That is our solution to our system. That's where they intersect, right? Do you have any questions about that? All right. What are the 3 ways that we use to solve systems of equations? First of all, what is a system of equations? Yes.
The 4x plus 2y
Well, what's the definition of a system of equations, is my question.
multiple equations.
Yeah, multiple equations, right? So 2 or more. That's when we're dealing with a system. There were 3 ways that we looked at solving them. What was the first that we learned about? Remember? Graphing. Remember when we graphed them and we found the intersection? That intersection was what we called a solution. Or if they were parallel, we said that they had no solution because they would never intersect. Or if they were the same line, they would have what? Infinitely many because they share all the same points. Graphing was the hardest. The good news about this final is that it's all multiple choice. You can use whatever method you want. And it is something where you can use your calculator. So I would make sure you bring a calculator that you're extremely comfortable with for the exam. What's another way? Elimination. And what's the last way? Substitution. Some of you, the substitution elimination one on the exam was quite difficult, I will say. I looked over it again and it was a little bit tricky. A lot of you got it. Some of you kind of gave up a little bit. So if you need help on substitution and elimination because you didn't get it the last time, make sure you pay really close attention to it now. Yes?
On the part of the question,
Mm-hmm.
is it a solution or is it not a solution?
So -2, 0 is a solution for, it says, tell whether the system is a solution of the, oh, that's not a solution, you're right. This point is not a solution for the system itself because it is not a solution for both equations. Yeah, I'm glad you said that. So this is not a solution for our system. This is not a point of intersection because it doesn't work for both of them. So not a solution. Does that make sense? It has to work for both. I think I addressed this last time when we were first learning it. If you plug in -2, 0 and it doesn't work for one of the two, then you do not have a solution to your system. Thank you so much for asking that question. Does that make sense? So this is not a solution because it has to work for both this one and this one. Because it has to be a point where they intersect. Any other questions before we actually start tackling some substitution elimination? Will you be asked to solve by graphing? No. And I wouldn't. Unless you like to, but I wouldn't. So try this. This is the easiest case. So for this one, what method did you use? Substitution. Remember, it's often easiest when we have an isolated variable, meaning a variable by itself, to use substitution. So we have a y by itself, so it's easy to substitute that y into our other equation. So when you have an isolated variable, use substitution to your advantage. So I'm going to take this y and I'm going to replace it up top. So that y is going to be replaced with a negative 4, and I'm going to solve for x, and then I'm already given my y coordinate. So negative 8x plus 2 times negative 4 equals 8. So negative 8x minus 8 equals 8. Negative 8x equals 16. X equals negative 2. That what you got? Okay, so negative 2, negative 4. Before you turn in your final, I would go back especially to these and double check them. Meaning, plug these into both equations and make sure that they are both true. Just like to address Daniel's point earlier. Because if they're not both true, when you plug in this point, if it's not true for this one and for this one, then you messed up your system somehow. Okay. Any questions? Let's try this one. So we have a couple different options on this. You can do elimination, you can do substitution. Either one is not that bad. What method did you use? Elimination? Okay, let's use elimination. So if we're going to eliminate a variable, which variable did you eliminate? X? X or Y? Either one. I'm going to eliminate X. That's what I did. It doesn't matter which one you start with. So if I wanted to eliminate X, I need to just make one of them negative, right? Doesn't matter which one. Let's just make the first one negative. So if I make the first one negative, I'm going to have to multiply that entire first equation by what? Negative 1. So that negative 1 times x minus y equals 8, and that 8 is also multiplied by negative 1. So now I'm dealing with negative x plus y equals negative 8. Then I have x plus 3y on the bottom equals 4. All I'm going to do now is add. With elimination, we just add. Straight down. Negative x and x, that eliminates. That's what we want. Y and 3y make 4y. Negative 8 and 4 make negative 4. So y equals what? Negative 1. Now that we know that, we're just going to plug it into one of our original equations, right? Either one. So let's just plug it into the first one. X minus negative 1 equals 8. So this is x plus 1 equals 8. So what's the value of x? 7. So my ordered pair is 7, negative 1. Okay. Check to see that it is a solution for both. So when I plug in 7, 7 minus negative 1, is that going to get me 8?
Yeah.
Yep. When I plug in 7, the 7 plus negative 3, is that going to get me 4? Right? So this is the point of intersection. That is a solution. So do double check. Do you have any questions? Do you need to try it a different way? Did you not get that? Did you get that? You're good. Good? Okay, great. So, another one, I think. Here we go, we have one more. Now, what's a good method to use here? You could use elimination. I would use substitution, actually. Get x by itself, isolate x, and then just plug x into the second one. So as I said earlier, it looks easiest to use substitution simply because I can get that x by itself on the top. How would I do that? Yes. Divide by 6. So when I divide by 6, I get x equals negative 10. Now I'm going to substitute that into the bottom one. I get negative 10 plus 4y equals 6. And then I solve. So I add 10, 4y equals 16, y equals 4. Okay, what you got? 8. And so now I'm just going to plug it into one of the originals. Well, the second one. That's the only one I can plug it into because there's no y on the first one. So, actually I don't even have to plug it in. What do I know x is? Negative 10. So what's my ordered pair? Negative 10 to 4. And again, just double check that the bottom one makes sense. It's negative 10 plus 16. Is that 6? It is. So that works. Questions on that? Alright, take about a few minutes. Get up, stretch, do whatever, and then we'll get started. What's the answer to number 50?
No solution.
No solution. Why? Why though? Yes.
Because they're both the same.
Yeah, the same slope. Right.
I read your mind different.
If they have the same slope, then they're never going to intersect, which means they're never going to have a solution. So this is no solution. Okay. The next one. Did you use substitution or elimination? Elimination. I did substitution, but we'll do elimination. Okay. So I'm guessing you eliminated the x.
Yes.
So I'm guessing you multiplied the top by negative 2.
Yep.
Alright, so let's do that. If I multiply the top by negative 2, I get negative 2 plus 4y equals negative 12. Oops, negative 2x. And then you have 2x minus 5y equals 16. So you have negative y equals what? 4? So y equals negative 4? Good, that's what I got. And then you just substitute it back into, I'm guessing, the top one? Alright. So x minus 2 times negative 4 equals 6. So x plus 8 equals 6. So x equals negative 2. So, and this is what I got with substitution as well. So negative 2, negative 4. Is that what you all got?
Yeah.
If you didn't, hopefully you saw what you did wrong. Again, how can you see if this is correct? Plug it in, and when you plug it in, what are you looking for? Yeah, that you get 6 at the top and 16 in the bottom, right? Excellent. Any questions about that? Okay. Let's give this one a try. The members of the Boosters organization at your high school bought new baseball equipment for the school. They spent $18 per baseball glove and $24 per catcher's mask, spending a total of $612. So right away we can make one equation in our system, correct? We have to first of all define our variables. So we'll have an X and a Y, just for simplicity's sake. What can X stand for?
$18 for baseball.
No, not X stand for. What can X stand for? Yeah, we can do that. So we'll do baseball gloves. Guys, make sure you're paying attention to this one because this one will show up on your test in some way, shape, or form. And this is not an easy one. And we'll do this one as the mask. We know that it's $18 per baseball glove and $24 per catcher's mask for a total of what? $612. That's great. I'm acknowledging you. Great job. Okay, so they bought 8 more masks than gloves. Guys, okay, we're recording. They bought 8 more masks than gloves. So how can I express that? Y equals what? Yeah, y equals x plus 8. So y, the amount of masks, are going to be the same amount of baseball gloves plus 8 more, right? Does that make sense? So what method will you have to use to solve this? Substitution, yes. So use substitution to solve it, and you get 18x plus 24 times x plus 8 equals 612. Yeah? And so when you do the distribution, you get 18x plus 24x plus 192 equals 612. Combine your like terms. You get 42x plus 192 equals 612. Subtract 192, isolate your variable, and divide. You get x equals 10. So how many baseball gloves did we buy? We bought 10 baseball gloves. And how many masks? 18 masks. Alright, that's it for today. We'll finish it tomorrow. This is question 52 out of 60. If you feel comfortable with these 52 questions, you're in very good shape. You're fine. If you don't feel comfortable, I'll see you tonight.